Hey you guys, welcome back. So today's lesson is going to be about something called the empirical rule, and that's like a crazy big math term. We're going to go into exactly what the empirical rule means, and then we're going to use it to solve some problems about statistics. So let's dive in. First things first, make sure you printed this notes out from Google Classroom, and if you don't have a printer at home, then you can just use some blank paper and follow along. The good news is that for all of the videos that I post for you guys, you're in control, so you can pause, you can rewind, you can skip ahead, whatever you need to do in order to get everything down. You can go ahead and do that. As always, please make sure that you're putting your name at the top of anything that you submit to me. You're going to put your period number, and you're going to put the date. So this is going to be the 15th. And something else I want to point out is that this does say topic 8 at the top here. We're calling it topic 7 because I skipped part 2 of measures of spread, which was the last lesson that we covered. So this is going to be actually considered topic 7. Okay, so the empirical rule. Let's assume that we have a data set that is so large that we don't have a set of values. So this is vastly different from the ones we've done before, because everything we've done to this point, you've had a list of data. You've had 20 weather temperature recordings, or you've had 15 people on a sports team and you have all their heights or something like that. In this situation, we have a set of data that is so large, so it could be 100, 500, 1,000, a million, who knows how many pieces of data. And the only information that we have been given about the data is some summary statistics. So we have the mean and we have the standard deviation. Now it's also important that they told us that this is a normal distribution, okay? Mean of 16, standard deviation of 4, okay? This doesn't really apply if you don't have a normal distribution. If you have something skewed, then there's a whole different set of rules that you follow. Okay, but we're working only with normal distributions right now. Remember, a normal distribution means that when you have your data plotted out, whether it's a histogram, a box plot, a dot plot, whatever, the shape of that data is sort of like bell-shaped like this. Okay, that's what a normal distribution is. Okay, so label the distribution below with the values using the mean and the standard deviation. Well, we know that the mean is going to be an average, and the mean is a measure of center. So in the middle of this data, we're going to label the mean, which is 16. Okay. And then we also need to label the standard deviation. So remember, standard deviation explains how far away data is from the mean, how typically far away a point of data is away from the mean of that data set. So the most that we can really do is we can go in chunks of 4 to the left and the right of the mean. So the first thing we're going to put here is we're going to put a 20, because that's plus 4, and then we're going to put another plus 4, which would make this 24, and let's go the other direction too, making sure we're using the same width the data is here. So 16 minus 4 is 12, and 12 minus 4 is 8. Okay. Suppose one of the data values that you have in the set is 20. An observation of 20, that point of 20, is that it's blank standard deviations away from the mean. Okay, so what we need to figure out here is what's the mean and what's the point we're looking at, and what's the difference there, and how does that compare to the standard deviation. So here's 16, that's the average, okay, that's the mean, and then 20 would be over here, and 20 is exactly 4 spaces away from 16, and they also told us the standard deviation is 4. So it's 1 standard deviation away from the mean. I guess we can put larger than or greater than. Okay, The next thing we can look at is, suppose one of the data values is 8. An observation of 8 is that it's how many standard deviations away from the mean. So let's figure out what that is. Here's the mean, and here's 8. And what's the distance here? Well, we know that one set of 4, one distance of 4 from the mean would be 1 standard deviation. So another distance of 4 would be 2 standard deviations. So 8, the value of that data point, 8, is 2 standard deviations smaller than the mean. Suppose an observation is 1.5 standard deviations above the mean. So the value of that observation would be what? Well, let's think about what the standard deviation is. It's 4. So 1 standard deviation would be 4 away from the mean, and half of a standard deviation would be 2 away from the mean. So 4 and 2 is 6. So what's 6 away from the mean? Well, if you go to the mean, which is 16, if you were to go above that, it would be 16 plus 6. That'd be 22. If you were to go 6 below that, then it would be 10. Okay, so this says above, it's 1.5 standard deviations above the mean. So the value of that observation would be 22, because you're taking the average and you're adding 6 to it. We can use the empirical rule to understand the data distribution. So here it is right here on the right side of the page. The empirical rule tells us that approximately 68% of the values of the data are within 1 standard deviation of the mean. So what that means is, if I were to draw a picture, and this is a normal distribution, okay? What this is saying is that if this is the average, we're going to use the symbol mu to signify the average, okay? And let's go 1 standard deviation above and below, okay? This right here, this shaded area is going to tell us 68% of the data, okay? So let's label these points also. So this is going to be the average plus 1 standard deviation, okay? And this is going to be the average, which is signified by mu, minus 1 standard deviation. Okay, and the Greek letter that we're using for standard deviation is called sigma, okay? So, and this is probably brand new information for you, but from here on out, whenever you see mu or you see sigma, these values here, these Greek letters, they represent, mu is for the mean, and the sigma is for the standard deviation, okay? So here we have the mean plus 1 standard deviation away, and this is the mean minus 1 standard deviation. So within 1 standard deviation, that would be minus it and plus it. Okay, this area right here is 68% of the values that are inside this data set, okay? And if we were to take that 1 step further, okay, I'm going to actually use a different color to represent this, all right? Let's use blue. If we were to go 1 more standard deviation in both directions, okay, this would be the average minus 2 standard deviations, and this would be the average plus 2 standard deviations. What this is telling us is that 95% of the data points are within 2 standard deviations. So 95%. Okay, and I'm actually not going to draw the last one, but you would have 99.7% of the data, okay? 99.7%, that's almost all of the data points. Almost all of the data points would be in a normal distribution are within 3 standard deviations of the mean. Okay, I'm not drawing that one, but that's what's listed there. Let's just color code this. Okay, and then let's just also at the bottom here just take an extra note here, and we're going to say this symbol right here is called mu. It's a Greek letter. And this is going to be standing for the mean. And then the other symbol that we just used for the first time is called sigma. That's how you spell sigma. It's a Greek letter. And this is for standard deviation. Okay. So we're going to go ahead and turn the page, and we're going to work on some more problems related to the empirical rule. Okay, so let's do the let's practice problem. And it says, suppose the amounts of water that a water machine dispenses into plastic bottles has a normal distribution that is within the mean of 16.2 ounces, and the standard deviation is 0.1 ounces. Okay, so that means on average, anytime you go up to that water dispenser, okay, and you have your water bottle, okay, and you put the water bottle under a little dispenser thing, all right, it's going to go ahead and it's going to dispense on average 16.2 ounces of water. Now, that's going to be about 68% of the time, okay, and within that 68% of the time, it's going to be within 0.1 ounces of that average. So it's going to be between 16.1 and 16.3, almost 70% of the time. That's what the empirical rule is telling me, okay? And then sometimes it's going to be even a little more off than that. Okay, it's going to be 2 standard deviations out, more than 16.2 and less than 16.2. And that's only going to be sometimes. And then even further out than that, it's going to be within 3 standard deviations of the average, which is going to be 0.1 ounces times 3, either plus or minus. And that right there is going to be 99.7%. So almost every time that a person goes up to get water dispensed out of their bottle, okay, it's going to be within 3 standard deviations of 16.2 ounces, okay? Okay, label the distribution below with the values using the mean and standard deviation. So the mean goes in the middle. The mean is 16.2 ounces. And then if we were to go 1, 2 standard deviations, and then 1, 2 standard deviations, this would be 16.3 and 16.4 because we're only adding 0.1 ounces each time. Let's go the other way. That's 16.1 and then 16.0. Okay, the middle 95% of bottles contain between what ounces of water? Well, remember, according to our empirical rule, if I go back to my last page, the empirical rule says that 95% of the time I'm going to land between 2 standard deviations of the mean. So this is the mean. This range right here is 1 standard deviation away, whether it's above or below, and this is 2 standard deviations away, above and below. So 95% of the time, the middle 95% of these water bottles are going to contain between 16 and 16.4 ounces. And then 68% of the bottles have between what and what. Remember, to narrow that down to the middle, the 68%, the middle 68% are going to be within 1 standard deviation, which means it's going to be between the first standard deviation above and below the mean. So 68% of those bottles are going to fall between 16.1 and 16.3 ounces of water. Okay, next question is, what percentage of bottles contains more than 16.4 ounces of water? Okay, so that question we can answer, okay, if we were to only look at the percentage of data that falls from this part, 16.4 and onward, okay? So if we were to redraw this distribution, right? Let's redraw this real quick. Okay, there's our standard deviation. Our normal distribution. The middle is 16.2. 1, 2, 1, 2. This is 16.1, 16.0, 16.3, and 16.4. Okay, so if you think about this being the middle point right here, the average, and in between here and here is 68% of the data, okay, so that means this is the midpoint of that. So what's 68 divided by 2? Well, it's 34. So this is 34% of the data, and this is 34% of the data. If you were to look at 2 standard deviations out, remember 2 standard deviations contains 95% of the data, okay? So how much more is, this is 68%, okay? And this right here is 95%, so what's the difference there? What's the difference between 95 and 68? Well, if you were to take 95 and subtract 68 from that, you would get 27. So there's 27 more percent if you go out 2 standard deviations instead of 1. But I only really care about the halves of that. So what's 27 if you cut that in half? Well, it's 13.5. So this is 13.5% of the data, and this is 13.5% of the data. So my question now is, what happens if I go beyond this? Well, remember, when you go 3 standard deviations, okay, so 1 standard deviation is 68%, and 2 standard deviations is 95, 3 standard deviations is 99.7%. Then the question is, how much is left? So there is 100% of this data somewhere, right? 100%. And 95% of this data falls between 2 standard deviations, which means there's only 5% of the data left. So if I were to consider infinity on both sides, this would represent 100% of the data. But 95% of it is already described by this range between 2 standard deviations. So what's left? Only 5%. And you cut that in half because there's 2 sides of the data. So this is 2.5%, and this is 2.5%. And that's all that's left. So the question was, what percentage contains more than 16.4 ounces of water? And my answer to that is that whatever the percentage of the data is beyond 2 standard deviations above the mean is going to be what that answer is, and it's going to be 2.5%. Okay, the next question says, what is the probability that a randomly selected bottle contains less than 16.3 ounces of water? Okay, so to figure out the probability that a randomly selected bottle contains less than 16.3 ounces of water, we need to figure out how much percent of the data falls below 16.3. So I'm actually going to go ahead and I'm going to use the space I have over here on the other side of this paper, and we're going to do another diagram. So once again, I have my normal distribution, and I have my average in the middle, which is 16.2, and 1, 2, that's 16.3 and 16.4. And then this direction, we have 16.1 and 16.3. Okay, now we know that this is supposed to represent 100% of the data points we have that's in our set. We don't know how big the set is, we just know that we have some number of data points, and we're talking about 100% of that by looking at this graph, okay? So from this end to this end is going to be 100%. We know that between each of these standard deviations, there's a certain percentage of the data points because this is a normal distribution, okay? We already know that 34% of the data is existing here, 34% of it exists here, 13.5% of it exists here, and then if we go one more standard deviation out, we have another 2.5% of the data here. Same thing the other direction, and 2.5% of the data is here. Okay, they want to know what's the probability that a randomly selected bottle contains less than 16.3 ounces of water. Well, 16.3 ounces of water is one standard deviation above the mean. So we need to basically take everything up to this point, okay, and add that together. Because if any of those data points falls in any of these areas here, it would be less than 16.3 ounces. So we need to take 2.5. We need to add 13.5 to that, and we need to add 34 to that, and 34 again. And all together, so any time that a water bottle fell in this area, okay, that would be 84% of the data, okay, and that would be less than 16.3 ounces. So it's 84%, but the only caveat here is that this question is asking us about probability, and the probability of something happening is usually expressed as a decimal. So it's 84% of the time, but it's actually 0.84 as an answer, okay? The last question is, what percentage of water bottles contains between 16.1 and 16.4 ounces of water? I could use either of these diagrams for this. I'm just going to go ahead and use a different pen color, and we're going to talk about, we're going to use this one right here. So between 16.1 and 16.4, how much of the data is contained between those 2 points? And that is going to be 34, 34, and 13.5. So 34 and 34 and 13.5 added together is 81.5. This question is asking us for a percentage, so it is going to be 81.5%. Okay, and that's the answer for section F. Okay, the last thing we're going to cover here is actually going to be the try it problem, and that says choose the correct numbers to build a normal distribution graph based on a mean of 45.5 and a standard deviation of 3.92. And they also told you some of the numbers will not be used and some may be used more than once. That's fine. They're just giving you extra stuff here, that there's not enough boxes, okay, to use all of this data, okay? So the first thing we need to do is, well, it looks like the value representing the mean is right here in the middle, and they told us that it's 45.5. So we can fill that in, and we can cross that off our list here. And then what else? The standard deviation is 3.92. So if we were to go from 45.5 plus 1 standard deviation, that would be 45.5 plus 3.92, and I can't do that in my head, so we're going to use a calculator. 45.5 plus 3.92, we get 49.92. And that's in our list right here. We can cross that off. We need to also go one more standard deviation, so we're going to add 3.92 again, which is 53.34. And that's in our list. Yep, it's right here. We can go ahead and cross that off. The next part of the question is, let's go the other direction from the mean. So we need to take 45.5 and subtract the standard deviation once, and then subtract the standard deviation again. So 45.5 minus 3.92 is 41.58. And that's in our list. Yep, it's right here. Cross that off. And then let's do that one more time. So that's going to give us 37.66. Okay. Now let's talk about what else is being described here. So it looks like what we have is probably going to be percentages. So how much of the data is within 1 standard deviation of the mean? Well, if we use our empirical rule, that's going to tell us that 68% of the data is contained here. 68%, and we can cross that off our list. And then how much of the data, what percentage of the data is going to be between 2 standard deviations? The empirical rule tells us 95% is between two standard deviations, so we can cross that off the list as well. And then it looks like inside here, we're going to do what we did down here, which was break the percentages in half, because this whole thing is 68%, but on just this half side of it, you need to take 68 and divide it by 2. So that's going to be 34%. And then if you split that in half, the other side would also be 34%. And we already calculated this because we're so good. So we know 13.5 goes in this slot, and 13.5 goes in this slot. Now you can see we did not use all of the things they gave us. Okay, wait, there's two 34s, so I'll cross that out, and two 13.5, so I'll cross that out. Okay, so we still didn't use all the data that they gave us, which is totally fine. But we have filled in all the boxes, so we're good to go on this one. Okay, you guys, that's it for the notes for the empirical rule. This is kind of it's a tricky topic to talk about, and it's the first real foray into summary statistics in terms of what a normal distribution is supposed to look like when you do not have the data. Okay, this is the first time we've done it without the data. You just have what the graph looks like, and you're told that the data is a normal distribution, so you have to make some assumptions. Okay, so I would implore you, if any of this was confusing to you, just rewind the video, watch from the beginning, try one more time to follow along now that you've gone through the whole thing. And please come to my office hours if you need additional help. Those are on Tuesdays and Thursdays from 10:30 to 1:30 on Google Meet. Okay, your assignment that goes with this is going to be posted into Google Classroom. So remember, submitting a photograph of your notes is going to be worth points for your grade. That's to show that you watched the video and followed along with me. And then the second part of your grade for this lesson is going to be completing the assignment, which will be posted on Google Classroom. Okay, you guys, thanks so much for attending class today, and I will see you next time. Bye-bye.